Writing formulas and naming compounds. When you begin writing or naming formulas, you're going to start with binary ionic compounds. A binary compound is one that is composed of two elements. But before you can start writing a formula, you must have all the needed information. So what do you need to know? Well, as we discussed before in the previous section, you need to know which elements are involved and what number of electrons they lose, gain, or share in order to become stable. So how can you figure this out? Well, we talked about the element's position on the periodic table and the number of electrons it gains or loses. This is called an oxidation number. An oxidation number of an element tells you how many electrons an atom has gained, lost, or shared to become stable. If you were to look at your periodic table, look at the number above each group. Many times this shows the oxidation number. It will either be a positive or negative number. Notice the pattern with the periodic table. Over group 1, you have a +1. This means that all the elements in this group are able to lose one electron. Therefore, it has an oxidation number of +1 because this element will now become positively charged when it loses that electron. Compare that to those of group 17, which are going to gain an electron. Therefore, they now have a -1 charge. When writing formulas, you need to remember that although the individual ions in a compound have a charge, the compound itself is neutral. So it's always good to double check that the compound you form has a net charge of 0. Here are the rules for writing formulas of an ionic compound. And let's remember, ionic compound means a metal plus a nonmetal. Now, once you find the oxidation numbers, go ahead and use these 3 steps. The first step is you are going to write the symbol of the element or the polyatomic ion that has the positive oxidation number or charge. Now don't get hung up on this term polyatomic ion. I'm going to go over that in a minute. I just want you to realize it's also part of this rule. Now it's important to remember, or it's helpful I should say to remember, that hydrogen, the polyatomic ion called ammonium, and all metals have positive oxidation numbers. So these would always be written first. The next step would be write the symbol of the element or polyatomic ion with the negative oxidation number. So nonmetals other than hydrogen, of course, and polyatomic ions other than ammonium all have negative oxidation numbers. The final step is to write the charge of one ion, and that charge becomes the subscript for the other ion. So make sure to reduce the subscripts to the smallest whole numbers that retain the ratio of the ions. This is where you're going to use the crisscross method. Remember, if the oxidation number is a +1 or -1, and you cross that down as the subscript for the other element, you do not need to write the number 1. Now, sometimes you're going to name the ionic compounds, and you can do that using these rules here. First, you're going to write the name of the positive ion, and then you're going to write the root name of the negative ion. The root is the first part of that element's name. So for example, for the element chlorine, the root is chlor, or for oxygen, the root is ox. The final step will be adding the ending IDE to the root. So chlorine would now be chloride, and oxygen would now be oxide. You don't have to worry about the subscripts when writing the names for ionic compounds because they do not become part of the name. However, they can be used to help determine the charges of these metals that have more than one positive charge. Now, let's go to polyatomic ions. Not all compounds are binary or only have 2 elements. Those that are composed of more than 2 elements are called polyatomic ions. The prefix poly means many, so the term polyatomic means having many atoms. This chart is one that you want to copy down and have readily available so you start recognizing polyatomic ions. So in order to name a compound that contains one of these polyatomic ions, again, you first write the name of the positive ion, then use this table to find the name of the polyatomic ion. So for example, K2SO4 is potassium sulfate. To write formulas for these polyatomic ions, you will also follow the same rules for the binary compounds with one small addition. Anytime a polyatomic ion is needed in the formula, you're going to write a parentheses around the polyatomic ion before adding the subscript. Now we need to remember that covalent compounds are those formed between elements that are non-metals. So some pairs of non-metals can form more than one compound with each other. For example, nitrogen and oxygen can form M2O, NO, and NO2. Now, if you were to use the naming system that we just learned for ionic compounds, then these compounds would all be called nitrogen oxide, and this would be incorrect. So scientists came up with prefixes to indicate how many atoms of each element are in binary covalent compounds. Now, if you had N2O, you would use this table of prefixes and know that having two nitrogens, you would need to use the prefix di. Therefore, N2O would be dinitrogen oxide. If you had an O2, then you would be called nitrogen dioxide, very similar to carbon dioxide. Now, when using prefixes, notice that the last vowel of the prefix is dropped when the second element begins with a vowel, such as pentoxide. It wouldn't be pentaoxide. And many times we don't use the prefix mono if there's just one element, although there are some exceptions like carbon monoxide. Sometimes you will also run into ionic compounds that have water molecules as part of their structure. These are called hydrates, and in a hydrate, there's a compound that has a water chemically attached to its ions, and then that H2O is written into the chemical formula. When writing a formula that contains a hydrate, you write the chemical formula, then a dot, and then the number of water molecules after it. I know there was a lot of information in this chapter, and it will take practice for writing formulas and naming formulas, but once you get the system, it's going to become very easy. What you want to do is begin to start recognizing if you're dealing with an ionic compound, which is a metal and a nonmetal, or a covalent compound, which is a nonmetal plus a nonmetal, and then start going from there. All right, let's take a break, and it's time to show what you know.